I noticed we are well over time already. Sorry for that. Right, yesterday we looked at building the first Go image from the first Docker image using Go in particular, right? So the idea was there basically. I'll just bring up the image we had. That we use Golang as a basis and indicate the maintainer of the system, run all the updates, then install the package and finally launch it. So that's very very straightforward, right? So no magic there. The next idea was then to think about, okay, how can we develop a more comprehensive application that also includes the database, and that's roughly where we stopped. So the idea there was that, okay, we have here a basic running version, and we modified it somewhat so it accessed the local database. That's as far as we got yesterday, and today the idea is to move ahead and see if we can create an additional Mongo instance and basically link that image to that instance. So we're basically running everything in Docker, at least the database and the underlying the web service. That's the key idea there. So and to that end, here we actually wrote a Docker file, so we had an explicit specification, but it may not always be necessary. For example, for Mongo, we have images. I think I downloaded an image yesterday. So Docker images, Mongo down here. Yep. So it should be relatively straightforward to directly instantiate that image instead of rewriting the Docker file underlying it. Fundamentally, it's still a Docker file, right? So if you look into the Docker Hub, you'll find that it's actually just doing that for us. So we can just take it from that very high level and conveniently instantiate it from here. So to run it, for Mongo, we need to specify the a volume where we store the data. So as of now, we pretty much stored all the data down here somewhere, and it looks sufficiently confusing already. So something has happened here. That's the prerequisite. So we need to have a container that we link to that particular location on the hard drive. So, and that basically works the following way: sudo docker run as usual. We give a name for the Mongo instance, so for example Mongo 01, let's say, and then -v for volume. Now we need to indicate the host's data directory you want to link to, which is data, and the corresponding directory on the image, so in the container. And then we detach that whole thing and use the Mongo image as the basis. So any magic here? No, that looks fairly straightforward. It creates a container and hopefully it continues to run. So sudo docker ps shows us all the running containers. ps-a shows all containers. We only have one running one here right now, and it seems to be listening on port 27017. So one thing I didn't do here when instantiating is, what didn't I do when instantiating the Mongo image? Something I've usually done when dealing with the Go image. Anyone? Related to networking? Yep.
Expose the port.
We didn't expose the port, right? So right now it's really we have a Mongo image here. That's running within the Docker instance, Docker host instance, but we're actually not exposing it to the public network, but potentially to any other interface or any other container that may be sitting here. But we're not exposing it via the host's network interfaces, right? So we don't have the link here. This would be the host, for example. Cool. So that's the key idea. So the idea is now to launch our existing Go container and hopefully have them interact only within the Docker network. So we actually don't need to interact via the public ports. The key advantage is we expose a minimum number of ports, so it has a security benefit of actually approaching it this way. So let's do that. First of all, just for the sake of transparency, I will rebuild the image. Let's forget where it sits. cd student docker. Cool. So that's the Docker file. If you have an existing, for example, let's put Docker images. We notice that there are some instances of the image already existing, but if you want to rebuild an image, you can obviously do that. Note that when you, so let's just try that. Sudo docker build -t student db, we get tag student db and tag 0.4, and we're using the current file as a current folder as context, meaning we use the Docker file in the current folder and build the image again. And you find it's going incredibly fast. Any intuition why? Anyone? No? Yep.
You haven't changed anything?
We didn't change anything, right? So, yep, that's right. So Docker's clever enough to figure out whether the image you're building is has underlying changes, right? Any of the layers have somewhat changed. And you see that because they basically have the previous image, 03 and 04, have the same image ID. Yeah. So in this case, it's just tagging yet another or adding yet another tag, but nothing else will happen because nothing has changed. But sometimes you want to reinforce a rebuilding. When would you want to do that? What would be circumstances that you want to reinforce or do a clean rebuild of an image? Yep, for example, right? So changing external resources. Yep, cool. And the simplest way or simplest thing was probably be that you want to rerun apt-get update, right? So it may change eventually over time. So Docker actually caches that, whether it has been called or not. And that's the simple, well, that's the indicator. So as soon as apt-get has been called, then this call is registered, but it doesn't necessarily reflect on the fact that resources, remote resources may change. Yeah? So it's something you need to consciously do. It obviously will do that if you don't have a previous image, but if you don't, then you need to do that. So I'll just delete the latest image, and if we look at the resulting overview, we'll find we're back to our 3 images. But let's do the rebuild and now actually do that, enforce it. So you can do that by saying no cache. This way it will always enforce a complete rebuild and download all the resources. So it's worthwhile to bear in mind, because that may happen to you, that you want to rebuild and you find that it's incredibly fast in building and there's actually no meaningful substantial change. So in this case, you need to reinforce the building. Obviously it can take time, especially if apt-get is involved, but yeah, that's part of the pain, I guess. All right, so while it's rebuilding, just let it do that. And then we'll see if we can link our 2 containers up. Just create another instance in the meantime. So you notice that that Docker is doing, even the building is done as a container here, right? So it's intermediate container images. You see them in the Docker PS output. Right now it's running apt-get, for example, and eventually it will be done, hopefully, perhaps. But it's basically creating containers, running them, and then disposing them afterwards itself. So it's totally ingrained the idea that it uses containers even for its own operations. But it also means if something fails, in principle, you can debug the individual layers. So as you see here, again, there are different layers of a container with intermediate containers in between. And if, for example, the building wouldn't work out, you could theoretically explore those and debug those containers. That said, that's not a conventional approach. In fact, it's not easy to inspect containers if they are not running. That turns out to be quite tedious. So let's see how we're doing here. TZ data, are we eventually getting something or not? You notice, yeah, there's an upgrade. TZ data needs to be upgraded as well. So sometimes it's worthwhile rerunning images. Please. Come on. Ah yeah, there's some progress. What are the images we have right now? Doing some stuff, has intermediate images. Ah well, then we try to continue with the older ones, 03 here, so our older tagged image. So let's run this thing again. So sudo docker run, run it attached first, so we have a bit more debug output. What else do we need to specify? Yeah, what are the aspects we need to specify to run the image? StudentDB, what were the aspects? We had it yesterday. Specific to the image, obviously. But it's important to bear that in mind when you write images, that you put this into the documentation, right? So you need to know the parameters that you need to run an image with. What were those? Please. Port, right, so it's environment variable. First we provide a name by convention. That would be StudentDB if it's not existing, 01. Port, yes, so be mapping to 8080. We got used to that, it seems. What else? Yep.
The environment variable such as the database.
Cool, yeah. So db host. Yeah, and the idea here is that we can use, we should now be able to link directly to a database based on the host name. Oh, it actually returns to us. So for that, I just want to briefly return here. Notice that we instantiated Mongo and gave it the name Mongo1. That's what's relevant here right now. So ideally, containers should be identifiable on that basis. So, so sudo docker run -- name student. There's no other one running, so we can just say 01. -p is 8080, mapping to 8080. -e is the environment. Environment is a port. Port is 8080. And we have another environment variable called db host, I think we introduced. So that's entirely image specific. And here we can induce then suggest that it should use Mongo1. Let's see how that goes. And one other refinement in terms of syntax. What else do we need to do? Is there anything else we forgot, perhaps? No. So yes, so then we can link it to the other container. So again, we use the container instance name. So it's important to have them named to do that. It makes your life a lot easier. 01. And the image we're building off from. So this one is still running. So we probably still need to fall back to student db3. Student db 03, and we'll try our luck, see how it goes.
What's the -it option?
Where did you see that?
I've seen it.
Ah, right, that's for interacting directly with the container. So if you want to run it and end up in the container and operate in it. But it requires the container to be runnable. So if it, for example, fails because of some weird error, then there's not much interaction that's happening. You will be basically leaving the container. Yeah. So if you want, we did this in the very first session when we talked about Docker, where we actually manually installed stuff running apt-get in the container, right? And once we're done, we exited the container and then committed the changes. Yeah. So that's the idea for interactive use. So this looks good. At least we don't get an error message. That sounds reasonable. While for whatever reason this build takes ages, it seems that it's probably an internet connectivity issue. At least that's my guess here right now, because it shouldn't be taking that long. So I open yet another instance. Notice again for debugging reasons, at least that's what I tend to do for the first run, especially when I'm not sure if things really work out. It's incredibly handy just to run it attached, meaning you don't use -d in your the -d option, meaning you actually see the output from a server to some extent anyway. So what we do now is just test that it's actually working. So let's see if we do a query get. Again, recall I had some made up, oops, it's not connecting to 8080. Hang on, why am I pointing to that? It's not connecting to 8080. That is not good. So, especially since I didn't see error output, that's not desirable. And it doesn't seem to have bound the port on the machine. Am I on the same instance here, hopefully? Student 1. Port 8080. My mapping seems okay. The name of the instance is that. Environment variables are exposed. Let's see. See what I could have done wrong. Let's try with single. Yeah, another interesting command, sudo ps-a. Notice when I sudo docker ps-a. When I run an image and actually doesn't work out, the container doesn't really work out or is stopped prematurely, you will still have the container dangling around here, right? So sometimes it's quite inconvenient to have this. So in this case, you can use the option -rm to delete the container once it's shut down. So in this case, you just append rm, and then it will just destroy the container in case once you shut it down. So you don't need to deal with the cleanup, because right now we still have that container there and we can't use that name again, so we need to use a different name, while in the same time our new container has been built, so we can work off the most recent image. So, and I hope that makes a change, we'll see. For whatever reason it doesn't, that's not good. That's not good. Ah, there you go. Something comes to light. It's very slow today. That should be way faster in terms of response, so I'm not sure what's happening. Right, so now we have something listening on the TCP alternative port, okay, which is 8080, so it seems just it's a matter of timing for whatever reason. Yeah. Oh, there you go. So this can come most likely come down to the OpenStack infrastructure. So again, you have multiple people working on the same shared infrastructure, and sometimes you simply don't get as much CPU time as you should get. So finally it's up, and we actually get our response. So yeah, so this just running here attached right now, but basically that's the key idea. So instead of using a local installation of Mongo, we're actually using now the other container. And the idea here is quite simple. We're linking to it using its name. So you need to indicate the link when instantiating it by suggesting --link. And in our case, since our code requires that environment variable to know which server to connect to, you also need to provide the name here, right? But this is specific to our application. This is specific to Docker instantiation amongst containers. So does it make sense?
Yeah, but now you have both a link and an external port.
Yeah, so okay, let's clarify that. So we have, how many containers do we run right now?
One.
Are you sure?
I don't know. I've seen one.
Okay. Anyone else? sudo docker.
You're linking to another MongoDB container.
Yep.
So you have two.
Two, right? So we have two containers. We have MongoDB, which started earlier. Again, I called this thing Mongo01. So just as the instance. So that's that one here. Mongo01. And this is our Go instance. Blue again. This is our Go service. And we call this thing student 02 right now. Good. And the idea is here in, so which network did we expose? Or what networks did we expose? Anyone?
Expose.
Yeah. What?
Like in the
port?
keyword expose.
Yeah, which ports did we expose? If you look at the containers here, you can actually read which ports have been exposed to the public network.
Yeah.
Which ones?
8080.
Cool. And nothing else?
27.
That's the question, right? So we exposed this port here to 8080. So you see it down here under ports, right? It's mapped against the all interfaces on the hosting Docker machine, right? Which is our class instance environment. And it maps port 8080 to port 8080 in the student 02 container, right? So specific to that container. Whereas in the other case in Mongo, we actually didn't do that mapping. Recall that we didn't have the -p specification, yeah? So it's actually not mapped against anything here on the host's port, meaning it's not accessible from the host perspective, yeah? So if you're accessing from the internet, there's no way you can access the MongoDB database. The only way of doing that is doing it via the internal Docker network, right? It's a bridged network. So the port 27017 as shown here is accessible for other Docker containers, but not outside of it. Make sense? Ish? Yeah? So it has security elements in it. And the addressing, which is kind of convenient, at least I find it very convenient, is you don't need to deal with any sort of IP addresses. In fact, we yesterday had the discussion, there are the underlying idea is actually to have IP addresses. So it's a native IP, it's a native IP network here in the Docker bridge. But we don't need to deal with this at all. Instead, we can just address them simply by indicating their name, their Docker container names. Yeah? Not the image names. It needs to be the container names, like Mongo01. Yeah? It's like DNS-based resolution, basically. Yeah? So if you point to that machine, it will try to connect to that database on port 27017, because the Mongo client, which is the default port for Mongo databases, and using this server name. Make sense?
Can you have multiple ports inside one container?
Yes.
And that
Yes.
you best specify the port.
That's right. So you can specify them all, right? So you can specify port ranges as well. That's right. And this basically just says which ports are available to the outside, but your Docker container can, for example, expose arbitrary number of further ports. Yeah. For example, if you have a web service and you only want to expose, let's say, an HTTPS interface, but internally you also have an HTTP interface for your web service for performance reasons, because you may want to invoke it internally from inside Docker, you can happily do that, and for outside connectivity only admit HTTPS connection, for example. Right? So in this case, you could only map port 443, but not port 80. Yeah, does that make sense? You guys know about the port 80 being the standard port for HTTP, right? So for web communication, and 443 for HTTPS, right? For anytime you have HTTPS in front, it defaults to port 443. So meaning you could selectively allow or prohibit the access to particular ports. Right? But again, we use the alternative port 8080 for our examples. Okay. Everyone clear so far what's happening here? Yeah? If anyone is lost, perfectly fine, because it's, again, we didn't do much on networking, I guess. Or if not, then now's the time. Just to clear. Yeah? But that's the idea. So you could have a Prince question? No? Yes? No?
I'm just scratching my back.
Okay, fair enough. So you could link an arbitrary number of different containers using that mechanism, yeah? Cool. All right. So now the bad news. The bad news is that this approach is actually considered deprecated. So by convention, the linking is a bit tedious and tricky. What's the downside of this whole approach right now? Anyone? Think about spinning up the entire system, if you like. What's the tediousness? What do we need to think about? Think about a larger system, let's say 20 services.
And just automate it so it's not tedious.
That's the answer, that's right. So, but what's the tedious bit about it? It's not so much only tediousness, but there's an element of complexity. What is that?
Links.
Yep. So we have implicit service dependencies, right? So for example, the Mongo DB instance needs to be started first before the web service can be started, because most likely it will just fail outright and your entire container will fail because it may not be geared for temporary unavailability of the Mongo database, yeah, things like that. Secondly, we need to be mindful, we need to remember pretty much all the parameters we need to inject into a given Docker container, right? So we still kind of need to keep track of what were all the environment variables, the pods we're mapping, and all that kind of stuff. And it seems still a bit kind of implementation centric. You can document it, of course, and perhaps to some extent automate it. But the idea is to move beyond this, and now that we have individual containers, now 2 in our case, we can actually systematically orchestrate them, right? So if you have 20 containers, you want to organize the startup order, you want to specify all the parameters, and basically have one command that brings everything up, right? One option is to write a massive bash script, obviously, but the other option would be to basically use Dockercompose, which is the next step from Docker containers. So we get to that in a second. So just to motivate that a bit. So right now at this stage we did some manual linking of containers, and that's the key here. So just to use the link statement. But simply the next step is to use a concept called Dockercompose, which allows you to move one level up. So we're moving beyond Docker files and images, but actually have a specification with respect to the order of starting and the resources necessary to run multi-container applications. Yeah? So we are now looking at, okay, what are the services and what do we need to specify? Fundamentally, it's always specified in one file called dockercompose.yaml. Can also be with an A, doesn't matter. This is fixed, you can't change that file name, or you need to comply with that specification, similar to the Docker file, which needs to be called Docker file. And what do we specify in there? Well, names of services. We have volumes that we need to specify in there, and potential networks. As I alluded to briefly before, there's different variants of networks in a Docker container. You could, for example, attach a container only to the host, so it's not accessible internally in the Docker network. It may not have any network connectivity at all. Or you may create your own networks inside there. We're not going down that route, but you, for example, could have a front end and a back end system where you basically expose only the front end to the user, right? So, and have the back end system communicate amongst itself without exposing to the front end for security reasons, isolation again. But the key things that we also specify there in terms of services is their names, environment variables, ports, building context, images. So all the kind of stuff we need to specify when we specify Docker run, right? So which is kind of tedious. And once we've done that, it should be as simple as to go to that folder in where we find the Dockercompose file and simply run Dockercompose up, stop, or whatever else. So basically do some runtime management, but it should be coming down to one simple command. That's the idea. Yeah. So and that's a simple example of that kind of YAML file. So the structure is different. We no longer have a kind of the Docker file approach of having individual instructions, kind of a bit of a procedural approach here, but rather here we have more declarative approach. We basically tell the system, okay, those are the services we want. Those is the images based from what are the volumes attached to it. What should its restart policy be? So restart policy is an interesting concept. Just imagine your Docker application, your Go application actually fails because it didn't find the database, right? So in our default case, it assumes that it has that the database is always available and can connect to it. But if that Docker container fails, Docker can control the fail-safe handling in the widest sense. For example, by restarting it automatically. Yeah, you could say no, I'm not restarting it because it needs to be inspected by responsible developer or whatever else, or you simply blindly restart that entire container. So you can automate that bit as well. You can mount. Oops, I didn't want to go down there. You can mount specific volumes, as we saw already, and you can also specify environment variables. Please.
Should the Dockercompose YAML be ignored by Git?
Depends. I know what you want to get at. Yes. So what do you want to get at?
Because you have the environment variables.
Yep. Okay, so we get down to that in a second as well. Yep, we deal with this because that's the problem. Exactly right. So, but that's the way of how to deal with environment variables right now. But you can also offload it into an external file, which you put into git ignore, and you can still commit your Dockercompose. That's the.
And a follow-up how you talked about Docker ignore.
No, I haven't. Should I? Probably should.
I don't know. Isn't it just copy paste what's in the git ignore into the Docker ignore?
That's right. Yes. So that's the idea. Yes. That's right.
Sibling.
Let me see.
Is there a reason why MySQL password is the same as this? I think it's an object below called WordPress.
Yeah. So, but the example here is just to indicate show different environments variables for different services, different containers, or. You mean the password is the same right now? Is that what you're alluding to?
Yeah, you're like using the word WordPress a lot.
Yeah, so that's just an example. In fact, that's not my example. It's actually from a Compose documentation. And it's just an exemplified use of environment variables. And it's obviously specific to the underlying application, right? So that's as far as it goes. The new thing here is, so we have basically two services, DB and WordPress. WordPress depends on a different image. It exposes the port, has the port 80 and exposes it to port 8000 on the host, ideally. And WordPress depends on DB. So, yep.
WordPress is not does not seem to be like a string. So what is WordPress actually?
What do you mean with string?
Well, I mean the value you are like you have like the environment and all these like
yep.
variables. And then you have like the value on the right, I assume.
Yep.
And what is the value of WordPress? Is it
yep.
supposed to be like a number?
No. Look at this. It's not JSON here, right? So we're not having.
Yeah, but if you look at ports down below, you have the actual quotes, from strings.
Yeah.
So is it like it doesn't matter if you use quotes in YAML?
It depends on the primitive you're using here. So in this particular case, in WordPress, it denotes a nested structure, which is indicated by indentation, but you don't need to use any sort of quotes because it's not a single value, it's actually a section. Right? See, that's an entire section that's related to WordPress. That's the descriptor for the WordPress service and all the associated properties.
Yeah, it's like an object.
It's like an object, but I think you're trying to merge it into a kind of JSON notation, which it's simply not.
Yeah, but
so
my point is that that's an object, but when you MySQL password would not be an object. It would be an actual value, like a string.
A string.
Yeah. So what
the question is this
a
string?
Right. Yes. Those would be string values. That's right. Yes. Yeah. But it will interpret it context dependent. So, for example, in the environment, everything is treated as a string. And under ports, because you can, it's an expression because you can indicate port ranges as well. For example, you could expose port 8000 to 9000 against port 80 to whatever, right, to 1080 or something on the host machine. So it needs to be interpreted by Docker. But for the rest, it's just it's string interpretation. Yes.
Yeah. So, but why does ports need that?
Because that's by convention. So I didn't write the specification, but there's an expression in there that needs to be evaluated by Docker, and I think that's the reason why they put it in quotations. Yes, but good point. But something to explore.
Because it has to be evaluated.
Yep.
Somehow.
That's right.
It's not in its final form.
That's right. Exactly. So the rest is basically just. Think about it, it's like concatenated into a large Docker command, right? So, and basically just execute it, whereas this may require some pre-processing. So, One of the aspects that's worthwhile noting here is that in Dockercompose it also allows the sharing of volumes. So the volume declaration here is, you find the same one down here. So you could, for example, use the same volume in WordPress and in the DB service, and basically map it to different locations on the corresponding machine. So this way you could basically link data folders across different containers, yeah? And they are stored in a third container, which is called a volume. Key difference between containers and volumes is that volumes generally don't run anything. They don't have any executable files, or at least don't run those executable files, but their content is persistent. So if you bring them down, the volume content is still retained, whereas the container one is not. Yeah?
So APIs would be volumes then.
Again, sorry?
APIs would be volumes then.
APIs? Just be more specific, what of APIs? Because we have an API in our Go service as well.
Well, if you write an API that you use in several Docker containers, you would reference it as volume, because it's not like an executable, but it contains files that are available.
You mean more generally like a library?
Yeah, I guess.
Okay, no. So the idea is they are it's similar to, yep. Perhaps you want to extend on it?
How about
Does it relate?
Database, persistent data in the database?
That's right.
Would that be in volume?
That's correct. So, so to get to those two things, number one, only the fact that you have a API, for example, a Go API and so on, only the fact that it's shared doesn't mean it should be kept in a shared folder. The idea is really about volumes is to have either large volumes of data, or like, I don't know, a big data set that all services work on, for example, or evaluate, or changing data. Data changes. Your API wouldn't change, right? Once it's compiled. So you just bring it up as a Docker container, tear it down afterwards, and gone. And if you start 5 of them, how big can it be, right, in its compiled form? Usually, like, our Docker files are, 7 megabytes or something? So that's a no-brainer. So you wouldn't start a volume for, you doing this. But if you have a database, then you would want to store the database content in a volume, so you can manage it using the same framework. But it may change, right? So, but there's two ways. We actually didn't use explicitly volumes in our current approaches. We actually mapped it against the host's file system. Yeah. So introducing a volume, which we are not playing around with right now, would be also at level. We have yet another volume in that Docker environment that we interact with. But what we did as of now, hi guys. Thanks. As of now, we're actually directly mapping the what was it? Data/db folder, which sits on the Mongo host. We're directly mapping it to the the file system of the host. Yeah. So we have a certain dependency on the host right now. Instead, we could have specified it and moved it into an individual container that is also managed as part of the Docker ecosystem. Yeah. So it's different approaches there. If you have larger systems, you definitely use containers, because you want to move it across different hosts. Right now, we're only working on one host. We're not dealing with swarms. That would mean moving containers between different hosts. Then it would be messy, linking it to a local host. But for our exemplified use right now, that's still kind of permissible, because we stay on that host, right? Yep, please.
Is it enough to just state the volume here?
Yeah.
And it automatically creates one?
It will automatically create one, exactly. As simple as that. The key thing is that you have a fixed identifier, same as with the services that you can refer to from everywhere else. So here, the volume is linked as DB data, and it's important that this key is identical. Yeah, you would specify all possible volumes, and then indicate which services use it and to which location in their local file system it would be mounted. In this case, on this location in the service DB on the file system. Yeah, please.
Would MongoDB be that /data/db on the local file system of the MongoDB container?
That's right. Yes, that's right. Yeah, that's right. So in this case, it's a MySQL example here. But yes, for we need to be specific to the, again, it boils down to the, I'll come to you in a second. It boils down to the implementation we are using there, right? So right now it's MySQL specific container, and then it will be Mongo specific. So it's really this gluing point where you glue the container specific information and environment variables, for example, together with a more bigger picture view on just services, right? So we're getting a bit more abstract in the specification here. But you're absolutely right. It needs to be specific to the services we're using. Please.
Under volumes, under DB, how does it differentiate between, how does it know that DB data is something that's specified down below it, not just a directory in the folder?
All right, because then you would have an absolute path specification, so you'd need to use the leading slash.
Okay.
So it would be leading slash data, for example. But this way, it will know that it's actually relating to volumes there. That's the idea. But the key magic here is really to use shared volumes. So you don't have one, let's say, one volume per service, but have the potential to use them across them. So it would be quite convenient. So you could even have one volume that has subfolders that relate to individual services, right? So you can just back up that entire volume and you're kind of sweet. Whereas this one doesn't need to be backed up because it's dynamically rebuilt anyway. Cool. Yep. There was a question there? No? Yes? Comment?
I think you can have dot slash on the...
Right, yeah. You can specify the same way as you could on the command line, context specific. But you wouldn't... Yes, you could do that, but you would need to specify the build context, which we didn't explicitly do here. So meaning, right now it actually doesn't tell which folder this thing is running in, because it doesn't need to, because it's just building off an image, right? So we have a ready-made image, it just blindly says use that image and go from there. But it doesn't actually say where the Docker command is executed. But recall, if we have a Docker file and we need to build from this, we actually need to know that location, right? In this case, we would need to have an absolute or a path to the Docker file that we want to build. We've seen an example of that in a second. Cool, right? So key features, just to highlight them, is the modeling of dependencies, right? So again, yet another example stolen from the documentation. Just very focused on that aspect is we have three services here, Redis, DB, and both of them are dependencies for web, right? And here you see the example of having a contextualized execution. So the build context is the current location, meaning the location you run Dockercompose in is the build context for the web service, and it will look for a Docker file in that one. Yeah. So we're basically delegating the execution to the Docker file, so it will be building the image first, and then you continue with the instantiation. Yep, please.
Does it look for it recursively?
Does it work recursively? You mean looking at subfolders?
Look, yeah, in subfolders for the Docker file. Oh.
I haven't tried that, and I'm not aware, but I doubt it. But I need to pledge ignorance. Yes.
Specify the folder.
That's right. So ideally, we would specify the folder, but also again, similar to the discussion where to put the Docker file. If you have the Dockercompose file in the right location in your Git repository, you pull this thing and basically run Dockercompose, then everything should be fine. So you can work with relative paths, right? So it should be fine as well. Example for the volumes again, just to clarify that a bit. So again, we have a volume explicitly specified down here with a simple tag, and this is how it's mapped, right? So we refer to it for individual services, and then identify the corresponding location within the image, right, for the particular service. So for this one, it would be in the backup service, it would that location here in that particular image, right? So quite straightforward. And coming down to the last aspect is the concern about environment variables, and absolutely spot on. We don't want to specify environmental variables in the Dockercompose file itself. In fact, we want to delegate it to external files such as .env that we did in earlier examples, right? So that's the way how you would do it. You can specify one or more of them and basically offload that issue. Okay, so I just put that one in here because it's kind of neatly highlights the idea of how it actually works out. So you should have your Docker files for the individual services along with your Dockercompose file in a Git repository. So everything is self-contained in here. And the only thing we need to do is basically pull that repository and run Dockercompose up, and it should instantiate all the individual services in the correct order, map external ports, for example 8080 in this example, and link individual containers as it's shown here. Obviously, again, that's not the architecture that we are dealing with right now, but the concept is exactly the same here, right? So the idea is that we have everything in a repository, and we pretty much are 2 commands away from running the entire thing, right? So, and that's what we're trying to, let's try to build that for our simple example with MongoDB and the student database. Is that everyone okay so far? Yep. No confusions?
I'm so far from okay.
Sorry?
I'm so far from okay.
Okay, yeah, I noticed that. Can I suggest another place of existence, such as the bed, for example?
No, I gotta work on the assignments.
Oh God. Right. Be mindful, yeah, and check your biometric measures. But you know, don't make it as forceful. If you're really sick, you're sick. So then there's no work. Please, yeah.
Is it possible to spin up all the 4 containers on Heroku in one, or do we have to use other?
Again, Heroku is the issue there, right? So the concept we are talking about here. So I'm not sure if Heroku has native Docker support. It may have, but Heroku per se is a pass service, right? So it sits on the next higher level. It basically looks at what is inside a container, and you need to comply to their specification as to what a service entails, a dyno. What we are doing here is actually running on infrastructure as a service system, so one level lower, right? So we're having a machine such as my class instance here that I'm running from OpenStack, and inside there you bring up the Docker instance. But that's right, most of the IaaS providers, such as Azure or the AWS, also have a Docker instance that they're offering you. So basically you can just send your request to the Docker instances. You actually don't need to deal with any virtualized physical hardware, blah, blah, blah stuff, right? You just instantiate it directly onto their Docker instance. That's the key idea. Yeah, but this is really going further because, again, you guys may have noticed we're talking about networking, all the lower level aspects like port mapping, things like this. So that's infrastructure as a service already, right? So one level lower, not something that we consciously deal with in Heroku. In fact, Heroku, it's inverted. They actually provide us with a port number. We need to deal with it, right? So slightly different relationship. So I probably give you until 12:20 if that's enough, and then we write up the Docker file or the Dockercompose file and see how we can bring up a service using that. So you have a few minutes to drink coffee, recover, find a bed, or whatever else is.